All right, so we already did the scientific notation stuff. Oh, I don't want this on here. What do I want on here? This. All right, there we go. Let me change this to this. Change that to that. And we're good. And let's turn this on, then we'll be ready to start. All right, so like I said, the test is going to be just like the quiz. Okay, it's going to be 1, 4, and 1, 5. It's just going to be more problems. All right, maybe a little bit more involved. Maybe, probably not. No more involved than this. This would probably be, yeah. So as far as these kind of problems right here, 7 and 8, it won't get any more difficult than that. You'll just have more of them. Okay. So again, you'll have scientific notation. So you might have 8 to 10 scientific notation, maybe 8. I'll probably give you more of these solving for X problems. So you probably have, maybe 12 off the top of my head. I don't know. Haven't even made the test up yet. I'm doing it tonight. So it'll be brand new for you. All right, so let's do this. I'll just go through these kind of quick. And if you have any questions on anything else, then we can do that. But it says to solve. So you want to solve for whatever variable they say. I think I put an X on every single one of these. So what you're going to do right here is distribute the 3 first of all. So distribute the 3. So if you have the quiz out, if you don't, you can have some notes out. Might be a good idea. If you got these wrong, this would definitely be a good idea. If you got them wrong on the quiz, you definitely want to write this stuff down. So here we go. We're going to distribute. So it's 3 times x, which is 3x, minus 3 times 2, which is 6. So that's the first step. Shh, don't talk. And then what we're going to do is we're going to add a 6 to both sides. I want to see the steps. I want to see. I know that some of you might be able to look at this and do this in your head, all right? But I want to see how you got the answer, okay? Not just what the answer is. I want to see the answer, obviously. That's going to determine if it's right or wrong, but I want to see how you got the answer. And this is how we show it. So that cancels. That's 26. Divide both sides by 3. Now, I said specifically when I gave the quiz, I said specifically, I think I even said this particular number. I can't remember exactly, but I think I said, at the very least, I said there is one problem where you're going to have a fraction, and I want you to keep it as a fraction. Well, guess what about 4 or 5 people did? They changed this to a what? To a decimal, even though I said don't change it to a decimal. Okay, so I do not want this as a decimal. I want this as a fraction. This can't reduce. 3 does not go into 26, so you just leave it like that. There is no reason to take any time to change that to a decimal. Not in this class. In other situations there might be, but not in this class. I want you to keep it as a fraction. That's it right there. This is the only answer that I'm going to accept. Okay? I'm not going to accept. I'm telling you right now. Okay? It's being recorded. I can go back to this and say, I taught this on October 30th at 11:45. I'm telling you right now, if you write your answer as a decimal, I'm going to mark it what? I'm going to mark it wrong. Okay? Because you're not following my instructions. All right? My instructions were to keep it as a fraction. So, keep it as a fraction. Now, if your fraction reduces to a whole number, then put the whole number. Always reduce your fraction. But there's no reason to change this to a decimal. I believe this is the only one out of this whole quiz that is a fraction, I think. Am I right on that? Somebody can tell me. All right, let's do this one. We got time, so let's do them all. So I'm going to take this 3, and I'm going to distribute it through here, just like we did right there. So you don't have to put those little marks. I just do that to teach. So I've got 6x minus 3. There's nothing you can do over here to simplify that, so I just keep that the same. Now I have to get the x's on the same side. Okay, that means I got a 6x on the left-hand side, a 2x on the right-hand side. I want to take that 2x, move it over to the left-hand side. So I subtract a 2x, and I subtract a 2x. So now I've got the x's all on the left-hand side. The reason I subtracted it is because it will cancel out. Then I brought it over here. Let me check. So he didn't show up at the office. That's nice. Take something so little and not really all that important. If he could have just been quiet, he wouldn't have been sent out. And now he doesn't go to the office. So now he took something so little, blew it up into this big old thing. All right? Don't know why. Got the x's on the left-hand side. Let's put the regular numbers on the right-hand side. So my x's are on the left. I want to get rid of this minus 3. How do I get rid of a minus 3? I add a 3 to both sides. All right? That cancels out. I like to do all that in one step right here. Now we can bring everything down. 6x minus 2x is 4x. And then this is 9 plus 3 is 12. Divide both sides by 4. I'll put it right here. X is 3. Don't leave it 12 over 4. You're like, Mr. Hammer, you just said, come on. You're not making sense. You said leave it as a fraction. But remember what I said after that. If it reduces, then reduce it. Okay, so this is your answer right here. Okay, if you left it 12 over 4, I'm going to mark it wrong. You need to reduce it. Yes? Well, I'm doing these first, and I'll jump back to those. All right, let's take a look at this. Let's get rid of this line right here just to get it out of the way. All right, so here we go. Let's do this in a different color. The thing we don't like about this are the fractions. So we have to get rid of the denominators. Getting rid of the denominators actually makes them not fractions anymore. So look at my denominators. I got a 3 here, and I got a 2 here. I had a couple people, maybe 1 or 2, I forget exactly, but I know somebody, they just multiplied this by 3 and they multiplied this by 2. You can't do that. All right, it does get rid of it, but remember, whatever you do to one side, you have to do to the other side. So I can't multiply the left side by 3 and the right side by 2. You're not doing the same thing on both sides, are you? So you have to do the same exact thing on both sides. So I want to multiply it by something that the 3 will cancel and the 2 will also cancel. So what number can I pick that 3 will divide into it, and also the same number 2 will also divide into it? This is 6. That's your common denominator. So I multiply this side by 6, and I come over here and I multiply this side by 6. But you got to be careful. See that plus right there? These are 2 separate terms. So I have to multiply all my terms by 6 as well. Since this 5/3 is being multiplied by the parentheses, we took a long time the other day to talk about this. I'm not going to get into that much detail. But since this is being multiplied, you don't multiply that x minus 3 times that 6 as well. It's already being multiplied when I multiply the left side. So if I multiply this by a 6 right here, this 2's got to also be multiplied by a 6. So I times it by 6. Question?
Can you go into detail of what you do?
No, I've done that. I've talked about that before. No, I think I've done enough. All right. So I multiply this side by 6. I multiply this side by 6. Again, if it's separated by a plus or a minus, you got to multiply both of those things by a 6, because technically, here's your little detail, technically you're taking that whole thing and multiplying it by 6, which means you're going to have to take that 6 and do what to it? Distribute it through. Okay, that's why you're multiplying both of them. All right, so that's the reason why we multiply both of them. Right here, you just multiply the fraction by the 6 to get rid of the fraction. Okay, since these are being multiplied together, you don't multiply both of them by 6. You just multiply the first one by 6. I'll go through it again. So watch. What if I had 3 times 5? The 3 and the 5 have nothing to do with this problem right here, okay? And what if I wanted to multiply that by a 2? Do I multiply the 3? Do I multiply the 3 by a 2 and the 5 by a 2? No. I only multiply either one of those, right? All right, so I could just multiply these together and get 15 and then multiply it by 2. Or I could just do what? Multiply the 2 and the 3, okay, which is 6, and then take that 6 times the 5, which is 30. It's the same idea. It's the same idea. This is like the 3. Whoops.
That wouldn't be the same number.
This is like the 3, and this right here is like the 5, okay? And this 6 is like the 2. Everybody see that? So I could take the 6 and multiply it by the x minus 3, but I don't want to do that because that's not going to get rid of my fraction. The whole idea of multiplying by that common denominator, that least common multiple, is to get rid of the denominators, to get rid of the fraction. Okay? Do you understand this right here? The 2 and the 3 are being multiplied. That's 6. times 5. Okay, how else could I have multiplied this? I could have gone, there's no distributing. There's no distributing in this situation. You only distribute when you have a plus or a minus. Okay, we talked about that right here. You only distribute when you have a plus or a minus, and you're multiplying everything by it. This is not a plus. I do not multiply the 2 by a 3 and then also the 5 by the 2. Okay, it's not going to give me the right answer. So I could go 2 times 3, which is 6 times 5, which is what? 30. Or I could go 2 times 5. What's 2 times 5? That's 10 times this 3, which also gives you 30. Or if you wanted to, you could have gone what? 3 times 5, which is what? 15 times 2, which is also what? 30. Okay, that's your situation right here. Okay? Your situation here is a lot different because of that plus sign. So I had to multiply this by 6 and I had to multiply that by 6. That's the detail. I went into it. All right, now let's actually do the problem. Multiply by 6, that 3 goes into 6 2 times. So I got the 2 times the 5. 2 times 5 is 10. And that's being multiplied by this x minus 3. All right, so that's what we have right there. All right, sorry. Taking care of that same situation. All right, so now we go ahead and we multiply this right here. This whole thing is being multiplied by 6. Again, we don't multiply both of them. We only multiply the fraction for the same reasoning as I talked about up here. So this 2 goes into 6 3 times. So I got 3 times 3, which is 9 times x minus 2. But again, I had to multiply that by a 6 because we're really distributing a 6 through both of these. So then I'm going to have the plus 12. So that's the important step. That's the step that gets rid of the fractions and turns everything into nice whole numbers or integers. Question?
So when we have the common denominator, right? When we multiply it, you have to go the denominator and multiply it. See how many times that goes into?
Yeah. 3 goes. Yeah, I said it. 3 goes into 6 twice, so I put a 2 here. I said 2 goes into 6 3 times, so I put a 3 right there.
You might be jumping ahead, but are we still distributing that 10?
Yeah. Now we're going to distribute. So now this problem is basically like these two problems. Okay. Didn't start off that way, but now it is. Except you're going to distribute twice though on this one. All right. So you're going to take the 10 and distribute it. So that gives you a 10x minus 30. Now you're going to take this 9, distribute it through this parentheses. So that gives you 9x minus 18. And then this 9 is not being distributed through this 12 because we've already distributed that 6 through it. So I just put plus 12. All right. One more simplification before we start moving stuff over. This is going to give you a negative 6. All right. Now you want to get the x's on the same side, so I subtract the 9x from both sides. I'm going to add a 30 to both sides because I got my x on the left-hand side, so I want all the other stuff on the right-hand side. So that goes. 10x minus 9x is just x, or 1x. Then negative 6 plus 30 is 24. And that's it. That's your answer. That's how you got it. Let's do this one just a little bit faster. Let's go back to red. I got a 5, a 5, and a 2. So what number does 5 divide into evenly and 2 divide into evenly? 10. That's the smallest number. There's a lot of numbers that they divide into, but 10 is the smallest one. That's the easiest one to pick. So what I'm going to do is multiply everything by 10. So I multiply this by 10. Now be careful. This is something we didn't have to do in the other one because we didn't have parentheses around it. So make sure you put parentheses around that. That's really important. Now, you do have that minus. So that 10 is being distributed through this whole entire left side, so I have to multiply that by a 10 as well. Come over here, do the same thing. Multiply that by 10, and then this is really important that you put that in parentheses, and you put a 10 right there. That first step is key. It really is. Make sure you're writing those down and you know why we did it. Now, because 5 and 2, what's the common denominator with 5 and 2? It's a 10. That means 5 divides into 10 evenly, and 2 also divides into 10 evenly. And that's why we picked a 10. So now, the reason that we did that, the reason we picked 10 is so that the 5 will cancel out here, here, and the 2 will cancel out. And now we're not left with any fractions. That's the whole key to this problem, is to not have any fractions. So now what we can do is take this 5. 5 goes into 10 twice. Okay? 5 goes into 5 once, so this cancels out to be a 1, and that goes twice. That's going to be a 40. Let's cancel out a couple other things before we bring everything down. Same exact thing here, right? 5 goes into 10 how many times? Twice. So I'm going to have a 2 times 8. Now you add a 2. This 2 goes into 10 how many times? 5 times. So we put a 5 right there. Make sure you're writing down every single one of these steps. Now let's clean it up so it looks a little nicer. All right? The 10 and the 5 cancel out. I got a 2. I got a parentheses. I'm going to write the parentheses down. You could, at this point, go ahead and distribute the 2 right now if you wanted to. And if you can do that, that's perfectly fine. I'm just going to show all the steps so you don't get confused. Right here, it's a minus, and then it's a 10 times 4, which is 40. Then you've got the x right there. Right here, what are we left with? A 2. 2 times 8. 2 times 8, 16. Minus, and then this 5 is being distributed through that parentheses. Okay? The reason I put parentheses here is because that 5 has to be multiplied by everything inside of here. And it's just a lot easier to show it in parentheses than to remember that you have to multiply it through. I would always put the parentheses in this situation. And now it's very similar to what we just did right here. Let's go through fairly quickly. So this is going to be 2x plus 4 minus 40x equals 16. This is going to be a minus 5x. Now, here's something a lot of people mess up on. That's a negative 5, isn't it? It's a negative 5. Minus 5, negative 5. It's the same thing. So it's a negative 5 times x, which is negative 5x. But it's also what? Negative 5 times positive 9, which gives you what? Negative 45. Okay? A lot of people forget that last little step right there. All right, let's add some like terms on the left-hand side. So 2x minus 40x is what? Negative 38. Oops, forgot the 3. Negative 38x plus 4. Over here on the right side, 16 minus 45, what's that? 29. Is that right? Negative 29? Somebody double check. Is that correct? Yes? I don't have it in front of me. It's supposed to be a 5. It's weird looking. Let's make it look like a 5. Check my math. 16 minus 45. That is negative 29, isn't it? I think so. 32. Yes. Okay. Let's do this. Let's get the x's on the same side. Now, I could put the negative 5x over here on the left-hand side, but that's going to leave me with a negative 33. You could do it. It's fine. No big deal. If you want to do it, go ahead. It'll work. But what I would do, I would add a 38x. Why would I do that? What's the purpose? Just to get a positive 33x. Okay? That's the only reason. If you're good with dealing with negative numbers, it's fine. Keep it negative, all right? Because you'll get rid of it eventually anyway. But I would rather just keep it positive. And then let's get rid of the 29, put it over to the left. So I'm going to add a 29. I'm going to add a 29. Okay? Add up those, I get a 33. Add up these two, right? It's a positive 33x. Everybody with me on that? See, the other way, you would have had negative 33x equals negative 33. And you could still get the right answer. It's perfectly fine. But, I just found out that, myself included, not just students, but sometimes we have a problem with negatives and it gets mixed up. And then what's 33 over 33? It's 1. If you had time, okay, put it back into the original problem, check it, see if it works. All right, let's do these. These are actually, I think, a little easier because you don't have to worry about any arithmetic. You don't need a calculator. You don't need to know how to add numbers together. Not really. All you got to do is know your know your steps, okay, for getting rid of stuff and moving stuff from one side to the other. If you know your steps, this really is not that hard at all. So it says, solve this equation. This is a formula, and it's an actual formula that we use. Anybody know what it is? A equals 1/2 b times h. What is that? The base times height. What's 1/2 the base times the height? Area of a triangle. Exactly right. Okay, so this is the area of a triangle. It's an actual formula that we use in real life. So we're trying to find the height. We're trying to find h, trying to get that by itself. Okay? Well, there's a couple things that are next to the h that we need to get rid of. So what is that? What's the one thing or two things we need to get rid of? The half and the b. All right? Now, I saw some people do this, not just one, 2 or 3 people, I think, did this. They divided by a half. And I completely understand why you would do that. Okay? And it's not wrong. I'm not saying it's wrong at all. The 1/2 is being multiplied. How do you get rid of something that's being multiplied? You divide. So I could absolutely see where you divide by a half, but I wouldn't do that. What's the same thing as dividing by a half? Multiplying by 2. That's a lot easier. So I'm going to multiply by 2. So what do I do over to the other side? Multiply what? That by 2. All right, so we already got the a over there on the left-hand side, so that cancels. Do you see how that's a lot easier than going a divided by 1/2? Because a divided by 1/2 is the same thing as 2 times a. But a divided by a half is not simplified. I can't remember if I gave that to you or not. Anybody want to volunteer that did that? Nobody? That's all right. I think I might have given it to you. I'm not really sure, but it needs to be like this. So now, again, I want to solve for h. What's the one last thing I have to get rid of? The b. It's just a regular b. It's being multiplied. How do I get rid of it? If it's being multiplied, divide it. So I divide that side by b, divide this side by b, and then there it is right there. It's as easy as that. You didn't really have to know any math, just that 2 and 2 divide into each other, but everybody knows that. Does that make sense? That's how your answer should look. All right, you can put the h on the left. It doesn't make any difference. Okay. Let's do this. Let's do the same exact thing. Well, not the same exact thing, but it's close to it. We're going to solve for t. So that's what we're solving for right there. And it says solve for t. We're solving this formula. And this is an actual formula that you use. You wouldn't use it in geometry or anything like that like you did this one. But this is like principal rate and time. Have you talked about that in any of your classes? Have you had classes where you talked about interest rates and things like that? Yes? No? Doesn't look like it. Nobody's saying anything. All right, so there should have been a time. Did you take Mrs. Frisk's class last year on Dave Ramsey? You ever take that, Mrs. Helton? Yeah, Ms. Helton, you probably talked about interest rates, didn't you, in her class? Yeah, that's what this is. So A is the amount. P stands for principal, which is the amount that you start with. A is the amount that you get after your interest accrues. P is for principal, R is for the rate, the interest rate, and T is for time. All right, I'm not going to delve into that, but we're just going to solve for T. That's all we're doing. We're just doing the algebra right now. So I got to get T by itself. So what is with the T? What's the first thing we want to get rid of? The what? The P. This one right here. Now it occurs twice, okay? But we get rid of what's being added or subtracted first, right? What if I had something like this? 3 plus 5 equals, I don't know, 8, okay, 8x. What if I had that? What if I had that? What do I, this is dumb. What if I said 81, okay? What do I get rid of first? I want to get the x by itself, right? Do I get rid of the 5 first? No, I get rid of what's being added or subtracted. So I subtract a 3 from both sides. Everybody see that? Okay. So what do I get rid of here? I get rid of this p right here that's being added. I get rid of that first, so I subtract it. So what am I going to have on the left-hand side then? I started off with an a, so what am I going to have now? Minus p, all right? And I got rid of it there. Everybody see that? I just subtracted from both sides. Now the rest is really easy. It's PR times t. I'm going to get the t by itself. How do I get rid of something that's being multiplied? I divide. So I divide by PR over there, and what do I do over here? Divide by PR, and that's t. Was I right? This was a lot easier than those other ones? Absolutely. Okay, it was faster, it was quicker. You just have to know what to do first. Over here, you're more familiar when there's numbers involved, but when there's letters, when it's all letters, everybody freaks out, like, oh, I can't do this. But it's the same thing as if they were numbers. It's the same thing. It's actually a little easier. Why do you think this is easier than if you had a whole bunch of numbers?
You don't have to calculate.
Yeah, you don't have to do any calculations. You don't have to do any arithmetic, right? You just put them where they're supposed to go. Okay, you subtract it, you divide, boom, you're good. You don't have to figure out what those numbers are. You just leave it like that, and that's your answer. Maddie, which one did you say? 4? Okay. So let's do this. Now, I'm going to change it on the test, and I should have put it here, but I think on the homework problems, it says, first, write all these in scientific notation, and then perform the operations, and so on, okay? So let's write all 3 of these in scientific notation. 4,000. First of all, my decimal is right here to begin with, isn't it? Yes? So where do I want to move it? I want to move it right there, okay? Because I want one number to the left of the decimal to put it in scientific notation. So I'm going to put 4, then I'm going to go times 10 to, how many places did I move it? 1, 2, 3 places. So what's this going to be? A positive 3. That's a bigger number, right? 4,000 is a bigger number, so it's a positive right there. So now I'm going to take that. Same exact idea, right? I'm going to go 3 times 10. How many places did we move it here? 1, 2, 3, 4 places. So it's 10 to the 4th. And then the bottom. Now this is a smaller number. It's less than 0. So what's my exponent going to be? It's going to be what kind of an exponent? It's going to be a negative exponent. So where do I want to move my exponent? I want to move it right after the 6. I want one number before the, or not exponent, but the decimal. I want one number before the decimal. So this is going to be 6 times 10. Now you don't just count up how many zeros. Right here, yeah, it worked. Count up how many zeros. But this, you count how many places did you have to move it. All right, so 1, 2, 3, 4 places to get it here. Even though there's three zeros, I had to move it 4 decimal places. So it's a small number, so I make it to the negative 4th. Everybody see that? So I change them all into scientific notation, and now I can work these out. So let's do this. Let's take the regular numbers that are out in front. 4 times 3 is 12 over what? 6. Let's do the tens. This is going to be 10 to the what? 10 to the 3rd, 10 to the 4th is what? 10 to the 7th. On the bottom is going to be what? 10 to the negative 4th. What do I do with this negative exponent? Flip it to the top. Okay, so what's 12 over 6 going to give you? 2 times 10. If I flip it to the top, it becomes 10 to the what? 4th. And then what do I do with the 7 and the 4? Add them up, right? It's a multiplication problem. 10 to the 7th times 10. That's supposed to be a 4 right there. It looks like a 9. It's a 4, so it's 10 to the what? The 11th, and that's your answer. It's as easy as that. There's a couple ways you could do it. If you wanted to, watch. You could have just done this right off the bat, taken that up to the top, and made it 10 to the 4th. You could have done that right away. It doesn't make any difference. All right, test tomorrow, 20 questions. You're going to start off the second marking period with a bang.